All right, hello Algebra 2. This is lesson 10.6, properties of logarithms. So just like exponents have properties. So x cubed times x to the fifth is x to the eighth. All we have to do is add the exponents, and that gives us the 8. And they have the quotient property. So if you have x to the 8th divided by x cubed, well, this is the quotient property, and it says all you have to do is subtract. So 8 minus 3 would be x to the fifth. And that's pretty interesting. So exponents and logs are inverses of one another. So logarithms also have properties very similar that allow us to add and subtract the logs. So we're going to start here. Today's lesson, I think, is really easy in Delta Math, which is super nice. So here are our properties. This is the first property, the product property. And the product property says that log base b of u times v. So here's our product. We're multiplying u times v. And we can expand that using addition. And so log base b of u times v can be rewritten as log base b of u plus log base b of v. And so if we have a product inside of a log, so usually this is the part that's in the argument there, then we can expand it using addition, the sum of the logs. Here we have the quotient property. You can see that we have, missed there, the quotient of u divided by v. So this is a quotient. This is u divided by v is in the argument of the logarithm. And so much like the quotient allowed us to subtract the exponents, here we get to subtract the logs. So we have log base b of the top minus log base b of the bottom. So top minus bottom. And you can see when we expand, we're basically writing the log over and over and over again. And here we have the last one, which is the power property. Power play, like to say. And you can see we have log base b of u. And then that u is raised to power p. And so what happens is the power gets to drop down in front, and then it multiplies log base b of u. So it becomes p times log base b of u. Now, whenever you see a number in front of a log, you can reverse that process and send it back up to its power position. And that's important to realize. So right now we have a very condensed expressions here. You'll notice that they have a single logarithm. Okay, and that's really important. We want to expand, and expand means we're going to write the logs all over the place, as many logs as we can. So right now when I'm looking, I have log base 3 of x squared times y squared. So because this is a product inside a logarithm, we get to add the logs. So I get to expand, and this is equal to log base 3 of x squared plus, you know what, I'm going to make that red, plus log base 3 of y squared. So the product property allows us to add the logs. Then we have the power play. So just like in hockey, there's power play. No, not exactly just like in hockey. We get to drop those powers down right in front of their logs. And so that power gets to drop in front, becomes 2 times log base 3 of x plus, and again, this 2 drops right down in front of its own log, 2 times log base 3 of y. And this is fully expanded, and that is a literal thing. It's as big as it can get. We've literally expanded it. We had something nicely shrunk, and we stretched it out. It's important you know how to expand, because the real reason we need to know this is because we need to be able to go in reverse. All right, so our goal is to actually be able to condense instead of expand. So first here we have our log, and you'll notice there's no base here. What is it if it's missing a base? There's always a base. No, it's not 1. It's 10. Log base 10. Remember, that is the common log. Log of x really means log base 10 of x. And that's 10 because our number system is base 10. Okay? So that is called the common log because our common base is 10. All of our, ones, tens, hundreds, thousands, those are all base 10 numbers. Okay, so first thing in my log argument here, that's what's contained inside the logarithm. The first thing we notice is that we have a quotient. So we're going to deal with that first. So the quotient property, if we have a quotient, then we get to subtract the logs. So that would be log base 10 of 5x minus, I'm going to do that in red. So minus log base 10 of y squared. So you'll notice I'm writing the base 10. It is not necessary, but I just want to point it out. So now this is log of 5x. 5x is inside parentheses. And so now that actually is 5 times x. And so that is a product that we can expand. And so that's going to allow me to add the logs. So that would be log of 5 plus log of x. And again, you could write base 10, but it's unnecessary. Okay, so you don't have to do it. I doubt Delta Math 122, they probably don't want to see it, so you can drop it. So we still have our subtraction sign. And then on y squared, that's a power. So the power gets to drop immediately in front of its own log. So that's the power rule, the power property, which drops your power. So the 2 drops down in front, it becomes 2 times log of y, or log base 10 of y. This is fully expanded. And again, I write 2 times just to remind you, but that little multiplication symbol isn't really there. I just like to write it to make it obvious. Okay. So you'll notice when you have things on top, they have plus signs in front of them. This is like a positive 5 here. And here we have positive x. When things are on the bottom, the y was in the denominator, it gets a negative in front. And that's important to notice. Oh, here we have a natural log. Remember, a natural log is simply log base e. What is e? Not quite 3. Remember, you have the e button on your calculators. It's above the natural log function, so you can do second e. E to the first is 2.71828. What is e? Not quite 3. It's just under 3. It's a crazy number, crazy irrational number like pi. All right, so we have x squared, times y squared over z cubed. So first, I see a quotient here. And so that quotient is going to allow me to subtract the logs. So that's going to be log base e of the top minus, I like that, you can just sort of make that bold and realize that, hey, that looks like a subtraction sign, just bigger. Log base e of z cubed. And then, of course, you can see, hey, here, look, in this logarithm, we've got a product and power rules. So you can do it in 2 steps or you can do it in 1. So we could say log base e of x squared plus log base e of y squared. See, I'm running out of room, so that's my problem. Let me move over here. All right, so we could say log base e of x squared. Inside a product, we get to add the logs plus log base e of y squared. And then we've got our minus log base e of z cubed. So then the last thing is our power play. All of these have a power to drop right down in front of their own little logs. And then I'm going to say it's best to go back to natural log, because log base e is fine. But math, we're lazy. And so let's just use natural log because it's easier. So this would be 2 times the natural log of x plus 2 times the natural log of y minus 3 times the natural log of z. And again, I just converted log base e is the same as natural log. You can just trade those out, okay? Log base e is really natural log. Log base e is really natural log. And you can just type that in Delta Math. You can just type ln, and it knows what it is, all right? You can just type log, it knows what it is. All right, a couple more here. So our rule with logarithms is that we don't want any radicals. No radicals. So we always want to use exponents. And like that's math from now on, is we always want to use exponents. So if you see a radical where you have the nth root of x to some power, you can rewrite that as power over index, right? Power over index. So we want to do that. So I'm going to rewrite this. Log, what's the base? Log base 10. This is z times y squared over, how do you rewrite the cubed root of x to the 5th? Yeah, we got to rewrite that. It becomes x to the 5/3 power, okay? So that got rewritten, x to the 5/3. Power of 5, index of 3, power over index. Now we see that we have a quotient, so that's going to allow us to subtract the logs. So log of the top, you'll notice that I crossed my z's. That's so it doesn't turn into a 2, minus log of the bottom. Here I have a product of 2 things. This is z times y squared. And so I can add the logs. So that'd be log of z plus log of y squared. Now I haven't done anything with the back end here. The last thing I want to do is drop any powers in front. So power play drops your powers. There's no power on this one, so it just stays the same. Log of z plus 2 times log of y minus 5/3 log of x. And this is fully expanded. Now, I have a question. Can you go from here all the way to here? Because I can. If I have it written in this form, I know that this is just going to be log of z plus 2 log of y minus 5/3 log of x. And if you can do that, that's great. I really want you to be able to just go from condensed to expanded, lickety split, one step. That's the goal. Let's rewrite this one. Natural log, again, we only want to see exponents. Natural log of x squared times y cubed over, here we have the square root of w. That'd be w to the 1/2 power. Remember, the index here is 2. And then we have the 5th root of z cubed. So that would be z to the 3/5 power. Power over index, 3/5. Now, in this form, you can go directly to expanding. I'm going to do it step by step and show you, but actually I'm going to go direct to the answer. Anything in the numerator gets a positive sign. Anything in the denominator, like x to the 5/3, would have a negative in front. So that's our goal. So fully expanded, my power drops down. So that's 2 natural log of x plus the 3 drops down, 3 natural log y. The 1/2 drops down, but it's in a denominator, so it's negative. So negative 1/2 natural log w. And again, z to the 3/5 is in the denominator. I'm going to drop my power. It's going to have a negative in front. So negative 3/5 natural log z. This is fully expanded. If it came from the top, it's positive. If it came from the denominator, it's negative. And if you can do that, that's fantastic. So here's how you would do it step by step. even though I want you to go here. So if you can get right there, great. First, we have a big giant quotient. So that would be the natural log of the top minus the natural log of the entire denominator. Whoops, that's supposed to be a w to the 1/2 times z to the 3/5. Okay, so first we had that quotient. Now inside we can, because we have a product, we get to use the sum of logs. We can add the logs. So it's going to convert to a plus. So that becomes the natural log of x squared plus the natural log of y cubed. Giant minus, and here's where it gets really tricky. We're subtracting this entire thing, and there's going to be an operation inside. So we have to subtract the whole thing, and this is where mistakes happen. And that's why you rather go directly to the answer. Just knowing things from the numerator get positives, things in the denominator get negatives, you're good to go, always. So most people forget to distribute the negative. So this would be the natural log of w to the 1/2 plus the natural log of z to the 3/5. And then you can see we'd have to distribute our negative, which again, that is the most common problem. Minus the natural log of w to the 1/2 minus the natural log of z to the 3/5. And now all of our powers can just drop right down in front, directly in front of the natural log, between the negative. There it goes. Okay, so you can see if you can get directly there, do it. I'd much rather you go straight there and not make a negative mistake. That's where most mistakes happen. So if you know that positives go on top and negatives go on the bottom, what we want to do is, if I give you this, can you go in reverse? Yes, you can. And in one step, well, 2 steps, let's say. 2 steps, it's really easy. So this is the ultimate goal. Being able to condense to a single logarithm, that's key here. And this is what's going to help us solve equations. So here we have a log minus a log, but before I do that, we're going to move our powers. Anytime you have a number in front, you get to move it back up to its power position. So k is going to move back up to a power. 7 is going to move back up to its power position. And I can rewrite that. So log of a to the k power minus, log of b to the 7th power. Now, what allowed me to subtract the logs? Of the quotient properties. So I'm going to write my single log, and then it's the quotient property, what goes on top and what goes on bottom. Well, a to the k goes on top, b to the 7th goes on bottom. Top minus bottom. And you only write the log one time. This is it. All right, I don't have a number in front here, but I do have a number in front here, or a letter. Power position, move those powers back up to their power position. Okay, so rewrite log of q, plus log r to the y power. So what allowed us to add the logs? That was a product property. So we're going to write a single log, and we're going to have a product of our 2 arguments. So that'd be q times r to the y, or just q r y. Log base 10 of q r y. Q r to the y. Okay. All right, same thing. I see a number in front or a letter, so I'm going to move it up to its power position and rewrite minus log of k to the z power. All right, again, what allowed me to subtract the logs? Quotient property. So log of a quotient. What goes on top? B. What goes on bottom? K to the z power. You're done. Super easy. Positive goes on top, negative thing goes in the denominator. Got a negative, that argument goes in the denominator. All right, let's see. Here we go. Move that 2 back up to a power spot. So log base b of 9 plus log base b of 3 squared. All right. So again, we have the sum of logs. What allowed me to add those logs? Log base b, that would be a product of arguments. So that's 9 times 3 squared. And we can simplify that. Log base b of 9 times, what is 3 squared? 9. So we're going to get log base b of 81 for a simplified answer. That's the goal, ladies and gentlemen. Top, because there's a positive in front. Bottom, because there's a negative in front. And you can always do that. Both of these had positives in front, so they both went essentially on top, if you will. Okay, that's it. This is the ultimate goal, is to be able to do this, and we'll be able to solve some more equations, and that's coming up next. Folks, please let me know if you have any questions. Don't forget about the help videos and Delta Math and the examples, and me. Of course, I'm always available. Thank you. Have a great day.